artificial intelligence or AI. It's all about making decisions or enabling machines to make decisions. Well, machines are already making decisions for us every day. Whenever you do an internet search on a search engine like Google and you get different results, these results are based on an AI application running in the backend. It's the same thing when you go to Netflix and you get recommendations of shows that you want to watch. These recommended shows are based on previous experience that the application had with hundreds and millions of users who use the application. Same thing with YouTube. When you get video recommendations, it's based on that. And now sometimes these recommendations you may not be the best or what you are looking for exactly, but the AI is not trying to give you exactly what you're looking for. It's more trying to keep you for a longer time on that application. And these might be a bit different. Nevertheless, uh, this is a form of AI that we see today and we use every day. Now, if your experience of AI is Terminator or Wall-E, these movies, well, this is a form of AI, but AI is a bit far away from being at that level, and it could be a disappointment for some who think that this is the AI that we're talking about today. So, what we will do today is we will go into an introduction and define some terms in AI. We'll see how AI works and how these programs are trained compared to traditional programs. We'll look at some real life examples where we see AI now in action or implemented already in different industries, from surveillance to industrial applications and automotive as well. And then at the end, we'll talk about the importance of AI at the edge, or why the edge is so important when it's combined with AI. Because AI doesn't need to be at the edge, it could be on a server, it could be on a data center, or on the cloud. But why the edge plays a major role when it comes to IoT and its importance in that sense. Before I deep dive into the agenda, I want to just let you know that AI is not new. It didn't start yesterday, actually. The first recorded AI program is as early as 1951 by Christopher Starchy, uh, who was the director programming research group of the University of Oxford. So Starchy checkers program ran on a Franti Mark I computer at the University of Manchester, England that time. And in 1952, this program could play a complete game of checkers at a reasonable speed. Well, for that time, that was impressive. So AI was there. What is different today from 1951 is mainly the technological advancement that we have and the processing power we have. That instead of having a computer the size of a room or a hall to run a small AI application, now we can run an AI application on a mobile phone or even inside your mouse or on a camera, let's say. So all this have changed, and it's making it easier for AI to be implemented on the edge and everywhere in different industries. Just to give a bigger picture, so AI is a wide name and it includes many things. So big data plays a main role in AI because it's the main component. To develop AI applications, you need good data. It all depends on the data you have. Now, big data is okay, but we can't use big data as it is. We need to have um, labeled data and data sets that are organized and vetted and with good quality. So we can take this data. This data is then gone into an algorithm like machine learning or deep learning that is trained to give us a trained module. And now this module is what we take and becomes our AI application. Sorry, this module becomes our AI application that runs on a computer, a device, an edge device, on anything. So let's look at the main definitions of acronyms. So artificial intelligence is a branch of computer science that studies and develops methods of simulating intelligent behavior in computers. In basic, it tries to mimic human decision making and intelligence into a machine. As simple as that. And this is a wide definition. Now, within AI, there is a lot of subcategories, and today we will be talking mostly about machine learning and focusing on this subcategory. And machine learning allows computers to build their own logic and to make predictions and decide things. Without machine learning, a computer needs a human to create algorithm code. With the machine learning part, it does that by linking relations between inputs and outputs, analyzing data that's provided by a human and labeled by a human. Machine learning can create an algorithm that links these characteristics together and start mimicking the decision making of humans or labeling things like humans do. Now, in deep learning, the algorithms are more of a form of a neural network and stacked in a hierarchy of increasingly complex abstract layers. Each layer uses information from the previous level to deduce a higher level or meaning and the recognition pattern. So this is a more advanced form of AI that mainly focuses on more complex things. So the more complex things are, the more unsimple is the application. We go to deep learning, and the results we get from deep learning are more accurate usually. And we will see, we'll talk more about this when we go to the examples and how these subcategories work. Now, just also to give a holistic view of the topic, computer vision is another part of AI that can have all what we talked about previously, and it enables mainly computers and system to drive meaningful information from digital images. So it's the part of AI that deals with the images and enables analysis and information deduction from videos and images. Another term that comes up always also in this definition is business intelligence. Well, this is not AI, I can say. However, business intelligence is the results of AI when you take it and you put it into a dashboard that can be presented for the use in a business case or to be presented to a C-level to take decisions based on that. This is the business intelligence. It could be also as simple as having this data summarized in a table for a technician on the site to act upon that. This is also called business intelligence. So business intelligence is taking all this results from the AI applications, all the metadata that you get, and putting it in an understandable and for humans uh, to look at and get results done. There are different types of AI learning. The first and by far the most common and most successful is supervised learning, where a human being trains a computer to figure out the relation between input data and solution through labels. It's very simple. Let's say you have pictures of dogs, you feed it to a computer and to an algorithm that tries to identify a dog. And we'll see examples on that later. Unsupervised learning doesn't use labels, but the algorithm is given a lot of data and tools to analyze this data and try to come out with an algorithm that works for us. An example of that is when we looked at the Google search, let's say, or Netflix recommendations. These are type of unsupervised learning where the algorithm by itself is always monitoring what's happening. There's a lot of data. There's millions of users using the platform. It takes this information, it runs it through and try to figure out what's the most show that is probably to be watched and then pops it on top. Same with YouTube. It keeps recommending the same videos because okay, the algorithm knows that this video is being watched more than anything else, so it will keep pushing it forward so people will watch it and spend more time on the platform. The third type of learning is reinforced learning, and this means that the algorithm learns from its mistakes. Especially in the beginning, humans must give signs for the algorithm on a good behavior and bad behavior. Over time, the algorithm learns to make fewer mistakes. This can be found in video games and industrial simulations, and so on. Google, for instance, and their data centers, they use reinforced learning to balance the power and storage opportunities on the servers. Now, having said this, let's look, where is AI today? So where do we find AI today and in which applications? First, we see AI in image recognition. Image recognition can be used to help detect medical issues, for example, within cancer diagnostics, or it can be used also in surveillance industry. Object detection and object recognition are the most interesting fields for the security industry, where the and camera can work as a labeler for the machine. So you can see a car, you label it with a car. You see a human, you label it with a human. This is one type of object detection and recognition that we see a lot. Character recognition is, of course, an old form of AI, where we see OCR, like optical character recognition, in printers since long time, and we also see now license plate recognition applications running on cameras and surveillance systems as well. We see it in speech recognition a lot, especially when you go and use Siri and Alexa. These are forms of AI uh, where uh, where it's in a speech recognition uh, use. And when we have pattern recognition as well, we don't see this obviously, but I've been seeing it or noticing it lately, and it's mainly used with financial institutions when they want to detect fraud on your account. So there is some suspicious activities, patterns that make them suspect that you're doing a fraud action, and sometimes even you're not, you're using your account, you do some transaction that seems suspicious, you end up with your account on hold. And this happened to me one time. So yeah, this is forms of AI, or where we see AI mostly today. There could be other than here. This is like a main list where we see it, and we will see in the examples later that AI is also available outside this applications as well. Before we go and explain how machine learning or AI applications work, let's try to understand how traditional programming works, and then we'll compare the process between the two. So, in a traditional program, the programmer tries to collect as much information about, and we'll take an example of identifying an object in a scene. Now, let's say a programmer wants to identify a house, a simple house in a scene, and then he can collect characteristics like it has walls, windows, door, and then he writes a program based on these characteristics. However, as much details as he puts in, I'm sure many will be missed, or the program will go endless. And again, when it comes to application, the accuracy of such a program wouldn't be as expected or as we would like it to be. And this is a traditional programming method. Now, if we look at an AI application and how the program is generated or the module is generated, it starts with collecting data. So we start by collecting data and labeling it and forming it into data sets. So once you have this data set, and this could be, in the case of a house, multiple pictures of houses from different parts of the world, or from a part where we're trying to run this application, we try to collect as much as we can pictures of houses and label them, and maybe also label what is not a house, so it understand that this shape is not a house, it's a rock or whatever. But mainly we're focusing on houses. So you have this set of data now ready and labeled and checked by a human. Now this set of data is fed into an algorithm that runs through and creates relations between the image and the labels that are there. So it keeps on learning, and the more data you have and the better data you have, the more accuracy you can get from this module. So it keeps on going through this data and trains a module that links relations between inputs and the outputs that do you desire. Now, once you have finished the program, this program you can take it and run it on a camera, let's say, But when it looks at a house, it tells you this is a house, this is not a house. Now, if you trained it to tell you this is a house, this is a building, it can label house, building, then you can add car later time, then you have a house, building, car. So it keeps on growing. Of course, with more options, more processing power is required, more labeling is required. But this is the concept of machine learning. You feed it data, it learns from data, and it goes from there. Now, keep in mind that once you have the program, it is what it is. It won't improve after running it. So you have a trained module that is being or run on your machine. Once you go out and start checking labels on the street, checking houses on the street, it's not getting smarter. The way you need it to get smarter is to collect more data, generate more labels, and then run the algorithm again to generate a new module. Or you can build on the existing module, but you need to have more data or better data to go from there. Now we'll take an example with more details on machine learning. So let's say we have we're trying to identify dogs and we get this amount of pictures, much more, like we have 1,000 pictures of dogs, and we feed them to a machine. And this is an example. This is for you to understand the difference. So now this data is fed into the machine, and now we have an algorithm that is ready to analyze picture of dogs. So we feed it a new set of pictures and we try to see if it will identify dogs. Well, we have our first miss. So it's not 100% perfect. So that's one. We keep on going and we see, yes, it's ticking all the boxes. They're identifying them. Now, keep in mind that these are not all dogs. Have you noticed that? So if you look closely, we have a donut, we have fried chicken, and other things in the scene. We have a muffin, we have a marshmallow, I think that. So yeah, it's not perfect, and the reason is these images look a lot like a dog. And for me, the first time I saw this, I also didn't notice that the fried chicken is a fried chicken. I thought it's a dog because I just quickly looked over it. So it's not 100% accurate, and this is machine learning. And as if you remember, I mentioned earlier, machine learning is a form. However, a subcategory is deep learning, where it's more complex. It's more of a neural network thing. Now, deep learning, where it's for more complex application, it's a layered application where we have a form of a neural network where every layer tries to capture characteristics of the object that we are trying to identify. Let's say we're trying to identify a dog now. Based on these thousands and thousands of images that we have, we identify what's the height of the dog, what's the width, what's the depth, what's the shape, what's the form, it has legs, it walks, it barks. So all these data, we take it in, or we don't need to take it in. The algorithm will define these data. So it will start taking characteristics of this object and defining it internally. And these could be endless characteristics. And then later, when you want to identify a dog, the accuracy goes up tremendously from machine learning. And that's why deep learning is the future. Well, because yes, we might need AI for simple things, but if we can run it for complex things, then the advantage comes there. So now deep learning can identify more complex scenes or more complex examples or applications in AI. I'll take an example, and this is a real example that was done on diabetic retinopathy patients. So these are patients who are diabetic, and this could cause to blindness if not detected. So what we had here, we had 130,000 images that were looked at and studied by 54 ophthalmologists or eye doctors, and we had a result of 880,000 evaluation output from the labeling. Now, all of this was fed into an algorithm to create a learning module. And now the learning module was used to look at the new results or new images of the retina to identify if they have this disease, the diabetic retinopathy. Now there was a lot of success in that part, and the results that we got from that they got whoever did the study was amazing, because the time it took for the AI to identify uh, if there is a diabetic retinopathy is much faster than humans, and the amount of error was much less, because now this AI application has the experience of 54 doctors combined together. And the more we have data, but it's always important to know that your result is as good as the data that you fed in. So if there was wrongly labeled images at the beginning, then the results wouldn't be accurate, and we wouldn't be able to depend on these results anyways. So where do we see AI successful today? I know we've mentioned where is AI, so now I want to look where we say AI is successful today in a holistic form. So it's successful where we have a limited scope, where we have a narrow AI, as we call it, when there is a large amount of data that is very specific. In the example before, we had 130,000 images, we had 54 doctors that resulted in 880 different labeled images. And these were only the correctly labeled images, or the most accurate, or the one we know for sure that they were labeled. So where we have large amount in data, and the second part is the clearly and easily defined labeling, so it clearly to identify what we want from the process. Now I will go and start looking at some examples. And the first example I want to talk about is from the surveillance industry. But before I go there, I want to go back and just remind you of how an AI module is created, or the finished program. So it's created based on the collected data that runs through an evaluation process and then results in a trained module. Now, this module is as smart as it gets. Once it's out there on the field, it's not getting smarter. Keep that in mind always. So, to get a better module, you need to update your firmware, or to get a new program from whoever did the initial program. Then you will improve the system. So in AI in surveillance, we see a lot of applications that run on the edge, on the server, and on the cloud as well. So we got this trained module from the slide before. So we have our trained module, and now we have it. We can send it into our wherever we have processing power. If it's in the edge, if it's on the server that can handle it, we go there. And now while these modules go through the videos that are being collected, they start to analyze the scenes, and they start to add information to these scenes. The information that we add to the scenes is called metadata. So this metadata can classify motion. Let's say if there's a motion in the scene, if there's a change in the scene, it can identify this as metadata, as a characteristic of the scene. It can classify objects, if there's a human, if there's a car, if there's a bus. So these are types of classifications that a camera today can add to a scene. So if you want to search later for a car that drove through this road with this color, let's say, you can put this, and it will give you only the scenes that has this object or characteristic. You don't have to go one by one and check, or through all the video and check it. It can also be event based. So if somebody crosses a line, if somebody spends more time inside an area, or an object spends more time inside an area. So all this uh, analytics that is happening on the image that is being captured is being labeled to the scene, is being collected, and now it's time to benefit from that. So the first use of this metadata is through for the surveillance system itself. So it's sent to your video management system with the video, and you can enable automated response and alerts, and you can also use it to, as I said, to search for forensic search for previous events. You can also use this data to trigger edge-to-edge events. So you have your camera, you have some other application running on the edge, you detect a human, you don't want him to be there, you can trigger a speaker on the edge to tell him leave the area, or after 1 minute where he shouldn't be, You've been more than 1 minute in this area. This is a restricted area. Please leave the area. So this is one use of this metadata or the analytics that we have. Another use is for business intelligence. Let's say you have you're working in you're a retailer, and you want to know when your shop is busy, when it's not busy, when you have people, how many people are on your queue line, when do you need to restaff. So all this information can be presented from the metadata, taken and presented into a dashboard form that can make it easily for the business to take decisions and improve its performance. Now, when talking about AI in surveillance, an important part of that is having a quality image, because if you don't have a quality image, you can't go further. And this is the first part. And here I want to talk about few things that are important for AI. For in general, it's important for every camera, but especially for AI, if you're running an AI application, you need to have a clear image. And for that, one of the things that is always difficult for a camera to identify or to work through is backlight, where you have a bright backlight, and you end up in a black image that, like the one you see in the first uh, column here. So to do that, cameras should be able to compensate for the backlight with a wide dynamic range and present a good image. Another thing is color fidelity and the contrast and the color of the image. So if you're trying to search for someone with a yellow t-shirt and the yellow is orange on your recording video, well, good luck with that. You have to have proper image to be able to use your AI applications. Same with vibrations, and cameras should have a fair and high quality electronic image stabilizer running on the camera to make sure that your images that are stored or that are captured live are not vibrating. And the fourth and last one I want to talk about is the light in the scene. So if you have a scene that is dark, it will be more difficult to identify objects in that scene. And that's why there is different technologies that help enhance the image with minimum light finder that works well with surveillance cameras. So all this is very important. Image usability is an important factor to use analytics in security cameras. One of the examples that I've been talking about, and here just to show you, so is AI-based object detection and classification. So cameras now can classify objects, being if they are humans or vehicles, and if they're vehicles, is it a car, it's a bicycle, it's what? Uh, and then it can run multiple scenarios at the same time. So once you have this identification, you can be innovative, you can be creative on the way you want to use it. So if you have an area where bicycles are not allowed, the area where cars are allowed, an area where waiting is only allowed for 2 minutes, let's say, so you track a car, go in, after 2 minutes you trigger an alarm. All these options are available, and most of the analytics now in surveillance industry go around this. Another example of AI is in manufacturing, and we see AI in manufacturing in different divisions, from maintenance to quality, production, R&D, supply chain. But today I will talk about quality and production. So these two things, I'll have examples on them. And the first one example I have is about quality. And here, if you see, I have an image of a car engine, and by no means this is not a real car engine from a car manufacturer, but this is an image I get to present an example. But this is how AI is being used in car manufacturing. So this engine, the camera or the will be trained, or the module will be trained on an image of an engine, a perfect engine. So it sees multiple images of well done inspected engines, and now it knows how it looks. And now when it's tracking the engines while they are being on the production line, it can detect if something is wrong, and it can label it. So now when it's labeled and it goes on, when the production is done, when at the end of the line, an AI application can give you a report, different plots. If it's green, it's checked, quality checked. If not, these are the issues. So a technician can go there and fix it This helps save tremendous time in inspection. You don't need to inspect every machine now. Only the ones that have issues need to be inspected, need to be fixed. So this is one thing from quality control. Another AI application, and this is something that some of my colleagues worked on. This is for a gas factory or production facility where they were trying to track the gas bulbs as they were going out to make sure they have the screw fitted in correctly. And in this example, you see the AI running on bottled water bottles, water bottles. So you see that it detects when a bottle with a properly fitted capsule, it detects it as green. If it's not properly fitted, it detects it as red. Well, this is a very basic application because you can easily have labels of thousands of images that are properly done or non-properly done, and then the machine can do this for you. This improves production, improves safety, and many things. So this is one of the uses of AI. And here you see the testing, not the real life. Another example is from maintenance, and this is from Volvo. And Volvo equipped around 350,000 of its trucks with IoT sensors that they sit under the driver's seat, and they collect data and analyze it and predict maintenance. And the results they got were amazing. So they shrunk the repair time by 25 percent, 70% less on the diagnostic time. So now they know what is there when the car comes in, when the truck comes in. They don't need to check it again, or at least they know 70% of the story. And uptime is much improved for the drivers because now you know you will have an issue if you don't go for service. So you take your truck for service before something happens. And now you save time on being more on the job than in the repair shop. So these were some examples on AI and where we see them. Now let's look at the customer needs and what is driving the evolution of analytics and AI. So mainly accuracy and enabling fast and event-based actions is a major contributor, especially in the surveillance industry or in security industry, because I can say like 10 years back, even just 5 years back, everybody was running on motion detection. And if you have a scene where you find motion, you trigger an alarm, and you have 1,000 cameras in your facility, well, imagine how many alarms you will get and how distracted whoever is looking at these cameras will be. And the worst, if you don't have anybody looking at your cameras. You want alarms popping up on your mobile or whatever. So accuracy is a major driver where we want accurate alarms based on intelligence pushed back to us as operator. Efficient search in live videos and records, automated alerts that enable proactive actions as well, so machine to machine integration and talking, and of course operational efficiency as using this data to do intelligent statistics and improve your business output, as well as flexible integration and edge-to-edge integration. So the fact that we see a lot of this metadata being standardized now, it makes it more it brings more appetite into it, because multiple people, you could have analytics running on your camera and you have another application that is analyzing that, and they are using this common language or standard language of metadata that they can communicate with each other. And this has been driving the industry or the AI in different industries tremendously. Now, I mentioned this briefly before. When we talk AI, it could be on the edge, it could be on the premise, or it could be on the cloud. What is the best for you? Well, there is no one solution that fits all. All these three solutions could be used together. You could use two, you could use one. However, today I want to focus on the edge and why the edge is so important for AI, especially in the surveillance industry. So when you're running your application on the edge, you're using the image or the captured video in its raw form before it is compressed into H.264, into JPEG or whatever. Whenever you compress a video, you lose part of the quality. So you're running your application on the raw video, giving you more information and better data to start with. Now, when you do this, you're also reducing your network traffic because you don't need to send the high resolution or the high definition video back to your server. You can run the analytics there, and then if you see a reason that you need this video to be kept, you can send it. So this reduces your traffic, network traffic, your bandwidth, reduces your storage capacity, reduces your also processing power in the server, and thus this reduces the power consumption or the power need in your data center, which overall is a more eco-friendly solution. So it's a tripling effect there. Also enabling real-time events and real-time integration edge to edge. And in cases like self-driving cars and others, you want to have this safety net that the edge will maintain to operate even if it's disconnected from the head end. So in case of cameras, you want edge-to-edge integration from a camera to a speaker to a siren to a strobe. All this is possible now because you have the data on the edge analyzed and knowing what to do based on what you have on the edge without depending on your server or the cloud. Improving scalability. Because of this edge independency, now if you want to expand your system, if you want to add more IoT devices to your system, you need less processing power on your servers. So you can add them easily without upgrading or updating your backend. The same existing backend that you have can handle more terminals and edge devices. And finally is privacy. And because you have the analysis on the edge, if it's being on an image, if it's being on the audio that you are capturing, because there's application that capture audio and analyze it, but okay, nobody wants you to record what they are saying on the edge, so you can analyze that audio that you're getting, and if you detect a gunshot, a break glass, you can take action based on that without recording this audio. And this is one example. So privacy is another uh, benefit for having your AI running on the edge. So how is the edge empowered today, and why we talk about the edge today? Because there is the technology available today to push these analytics to the edge. So we have advanced processing units that are application focused. They are deep learning by design. So they are designed to run deep learning processing, deep learning applications on the edge, allowing more complex algorithms to run on the edge while being more power efficient. Because they are designed to run this application, they have faster processing, less heat dissipation, and reduced cost. And all this is being available to us today, and it keeps on improving. We have more memory available on the edge now, and we have improved security at the edge devices. Being from a cyber side, and this is a concern for everyone. With the advanced processing power, we can have more coding, we have more vaults that are on the edge, hardware that can protect our equipment from being cyber attacked or being more cyber secure. And of course, we have a growing number of PoE devices that are available for AI and to run on the edge. So every edge device now has processing power, can be uh, an IoT device running AI. Now, one of the main advancement that I talked about uh, just now on the edge is the deep learning processing units that create new opportunities. They are enabling new application and use cases. We have increased robustness and we have this dedicated hardware for these deep learning applications, which we didn't have before. So for a long time, we had a lot of processors that supported machine learning, but deep learning, because it needed more power and we have limited power on PoE devices, we were always behind in pushing these AI applications that need deep learning to the edge. Now it's available, it is there, and we see a lot of improvement on applications that can run on the edge. Now, before I leave and give the floor back, I want to just remind you that AI is a tool, it's not a solution. So there's different applications for AI, but it's always a tool. So it enables machines to take decisions, but it's only part of a solution. It's a tool that can be shaped in many ways to improve our life. It's for us how to use it. So don't be afraid of AI. It's only here to make our life easier. It only depends how we use it. And with this, I want to thank you for staying with me till the end. Please subscribe to my channel if you haven't.